Today we are going to start a chapter that is sound. Now what is a sound? It is a form of energy. Say the particles of the medium, it is produced by vibrating the body, and because of this vibration in the particles of the surrounding medium, which travels in the form of waves with a certain speed, that is called a sound. Now there are some range of sound. One is called audible range. What is audible range? The sound within the limit 20 Hz to 20,000 Hz, it is called an audible range of sound. Because within this range only we are able to hear the sound. So if suppose the frequency of sound is greater than 20,000 Hz, then it is called ultrasonic sound. If suppose it is less than 20 Hz, then it is called infrasonic sound. Now, say sound depends on, say when the sound travels in a medium, the maximum displacement of the medium either side of the mean position is called amplitude. Say this is the transverse wave, this is called amplitude, this is the amplitude, and the distance between these two amplitude is called wavelength. That is, the distance between two crest and two trough is called, these two are called the crest and these two are called trough. TROUGH. Now this is your crest. Now with the help of this formula, that is V is equal to N lambda, or sometimes it is being written that V is equal to F lambda. F stands for frequency. Now what is the relationship between frequency and time period? Frequency is equal to the reciprocal of the time period. Now say the frequency of the wave depends on vibrating source producing the sound, while velocity of the wave and hence its wavelength depends on the properties of the medium in which the wave travel. Listen here, nicely you listen. The frequency of a wave depends on vibrating source. Frequency of a wave depends on the vibrating source producing the sound, while velocity of the wave and its wavelength depends on the properties of the medium in which the wave travels. The sound wave necessarily require medium for their propagation. The transfer of energy by the wave is through the vibration of the medium particles about their mean position. When the medium particles vibrate, there is a change of kinetic energy into potential energy and vice versa. So sound waves are also called elastic or mechanical waves. The mechanical waves are of two kinds. One is longitudinal wave, another one is transverse wave. Now this is your transverse wave. Now the longitudinal wave travels in a solid, liquid as well as in gas. On the other hand, if the medium particles vibrate normal to the direction of propagation of wave forming crest and trough, then it is called transverse wave. Why it is so called transverse wave? Because it is having crest and trough, the maximum as well as minimum displacement. A horizontal wave, say or longitudinal wave, travels in a gas without any change in heat content of the medium. The speed, velocity of the longitudinal wave in a gaseous medium is equal to root over gamma times P by D. Now, since the density of gas it decreases with the increase in temperature and increases with the humidity in it, so a longitudinal wave travels in a gas without any change in heat content of the medium. The speed V of a longitudinal wave in a gaseous medium of density D and pressure P is having a relation that is V is equal to root over gamma P by D. Now since the density of gas decreases with the increase in temperature and increases with the humidity in it, so speed of sound increases with the increase in temperature and with the presence of humidity in a gas. However, the speed of sound is not affected by the change in pressure. When a wave traveling in one medium passes to another medium, the speed, wavelength and intensity of wave will change, but frequency of wave will not change. Listen here. When a wave traveling in one medium passes to another medium, the speed, wavelength and intensity of wave will change, but the frequency will remain the same. The direction of travel of wave will also change except for normal incidence, if suppose I is equal to 0. Now the sound wave differ from electromagnetic waves. Example, gamma ray, X-ray, UV ray, infrared, microwaves, radio waves. The electromagnetic waves are formed by periodic vibration of the mutual perpendicular of electric and magnetic field in a plane normal to the direction of propagation of wave propagation. The electromagnetic waves are thus transverse wave But unlike sound waves, they can travel through vacuum. The speed of electromagnetic wave in different medium is different, and it is maximum equal to 3 into 10 to the power 8, which is equal to the velocity of light. The electromagnetic waves transfers energy in the form of photons. Now, the difference between light wave and sound wave. Light waves are electromagnetic waves, whereas sound waves are mechanical waves. Light waves travel in vacuum. Sound waves do not travel in vacuum. The speed of light wave is 3 into 10 to the meter, 3 to 10 to the power 8 meter per second, whereas here the speed of sound is 330 meter per second. The waves, light waves are transverse waves, whereas sound waves are longitudinal waves. Now, reflection of sound wave. Sound wave is just like other wave. When it strikes a hard surface, return back in the same medium, obeying the law of reflection and refraction. Now, because of this reflection of sound, an echo is being produced. If a person stands at some distance from the wall and produces a sharp sound, he hears two distinct sound. The original sound, which is heard almost instantaneously, and the sound heard after reflection from the wall, which is heard little later than the original sound is produced. The second sound heard after reflection is called an echo. The sound heard after reflection from a distant obstacle, such as cliff, hillside, wall of building, edge of forest, after original sound has ceased, is called an echo. The reflected sound, if heard along with original sound, it is not called echo. Only the sound heard after the original sound has ceased, that is, the sound distinctly separate from the original sound, is called echo. What are the conditions for hearing an echo? An echo is heard only if the distance of the person producing the sound from a rigid obstacle is long enough to allow reflected sound to reach the person at least 0.1 second. Now, we can calculate echo with the help of this formula. D is equal to Vt by 2, where D is the distance of the source from the reflecting surface, T is the velocity of sound, T is the time taken. With the help of this formula, we can have a relationship between velocity, distance and time. Now, if the reflector is at a distance of less than 17 meters, the sound gets mixed with original sound. If there are repeated reflections at a reflecting surface, the sound gets prolonged. This effect is called reverberation. If there are repeated reflections at a reflecting surface, the sound gets prolonged. It is called reverberation. It can be easily experienced in high tombs like Taj Mahal, Sikandra, etc. Thus, to hear echo distinctly, following three conditions must be satisfied here. Three conditions must be satisfied. What are those three conditions? Conditions are, say, the minimum distance between the source of sound and the reflected must be 17 meters. It is different in different media. Now, the size of the reflected must be large enough as compared to the wavelength of sound. The intensity of sound should be such that the reflected sound reaching the ear is sufficiently intense to be audible. Now, what are the uses of an echo? Say, the ultrasonic waves above a frequency 20 kilohertz, that is 20,000 hertz, are more energetic than audible sound. So, they are having three following properties. They can travel undeviated through a long distance. They can be confined to a narrow beam. They are not easily absorbed in a medium. Now, audible sound wave do not possess above properties. However, ultrasonic waves in a medium have same speed as the speed of audible sound in that medium. Uses of echoes by bat, dolphin and fisherman. Animals have a different audible range of frequency. Example, bat, dolphin and dogs have a much higher upper audible limit than a human being. Bats can produce and detect the sound of a frequency higher than 100 kilohertz. Bats fly with a speed much lower than the speed of sound. The sound produced by flying bats gets reflected back from the obstacle in front of it. By hearing an echo, a bat come to know, even in dark, the location of obstacle, so they can fly safely without colliding with it. This process of detecting obstacle is called sound ranging. Now, dolphin detect their enemy and obstacle by eliminating the ultrasonic waves and hearing their echoes. They use ultrasonic waves for hunting their prey. A trawler or a fisherman sends ultrasonic pulse from a source into the sea and receives a pulse reflected from the soul of fish in a detector. The total time t of the to and fro journey of the pulse is recorded. The distance d of a fish is then calculated, where v is nearly equal to 1400 meter per second. Now, what are the uses of sonar? See, the word sonar stands for sound navigation and ranging. So the principle of sonar, say, listen here, these waves are received after a reflection from an obstacle, such as enemy submarine, iceberg, sunken ship. To find the distance of the obstacle from the ship, the time interval t between the instant when the waves are sent and the instant when the waves are received. After the reflection from the obstacle is measured, the distance d of the obstacle from the source is then d is equal to vt by 2. Now, uses of echoes in medical field. In medical field, echoes method, ultrasonic waves is used for imaging human organs such as liver, gallbladder, uterus, womb, etc. This is called ultrasonography. Similar to echocardiography is to obtain the image of human heart.